Bismillahirrahmanirrahim. Welcome to the Structural Engineering Software Application class lecture number 7. Okay, in today's class, I will discuss how to model area element and how to analyze a multi-story building in SAP2000. Right? Along with this topic, application of group command, replicate, and insertion point command will also be discussed in detail. Okay, the lecture outlines are objective of this lecture: introduction to the area element, example on analysis of area element or slab, then group, replicate, and insertion point command will be discussed, and then example on analysis of multi-story building in SAP2000, and at the end, class task is given for student practice. Okay, lecture objective. By the end of this lecture, the student will be able to model area element and analyze multi-story building in SAP2000. Now, what is area element or slab? It is basically a 2D surface or area element having very small thickness as compared to the other dimension, length and width, and the best example of area element is slab. In the figure, area element is shown whose length and width is more than as compared to the depth, right? Okay, slab is usually constructed to create useful surfaces like floors, roof, and ceiling, and it provides shelter. And the slab is actually supported by the beams, column, wall, or the ground. Sometimes the slab is supported by the ground. Okay, in the figure, a slab example is shown where the load is applied on the slab, and the load is actually transferred from slab to the beams, corresponding beams, and then the beam load is transferred to the column, and finally it is transferred to the foundation and soil. Okay, types of slab. Mainly there is two type of slab. One is one way and two way. One way slab is a kind of slab whose length to width ratio is more than 2, or where the load transfer is along one direction, that is the shorter direction, right? And two way slab where the length to width ratio is less than or equal to 2, and the load is transferred in both direction, either in along IX direction and along IY direction, and it is actually two-way slab. Okay, now other type of slab, there is mainly 4 other type of slabs. One is a two-way beam supported slab, and this kind of slab is supported by a beam in both direction. And the second type is the flat plate, and in this type of slab, the slab is actually supported over columns only. And the third type of slab is the flat slab, and it is supported by a column, but the column is modified in the form of drop panel and column capital. Okay, so the drop panel and column capital is provided in this kind of slab in order to overcome the punching failure, right? And the fourth slab type is the waffle slab, and it is also called two-way joist slab, where the joist or we call it ribs are provided in both direction of slab. Okay, now analysis methods for slab. Unlike beams and column, slab are two-dimensional members. Therefore, their analysis except one-way slab system is relatively difficult, right? Okay, in case of one-way slab, bending occurred in one direction, and it can be analyzed like beam by considering a unit strip along shorter direction, right? Okay, for analysis of two-way slab, ACI approximate method are used, which are the step method, moment coefficient method, and direct design method. Okay, these 3 methods are used to analyze a two-way slab. Okay, but we can analyze slab very easily by using computer softwares, that is finite element based softwares, and the available software are SAP2000 and ETABS, and some other software we can use that for analysis of slab. Now I will discuss how to model slab or area element in SAP2000 with the help of example. Let's suppose the length of slab is 20 feet and the width is 10 feet, right? And the thickness of the slab is 6 inches, and 2 kip per square foot area load is applied, and the material type is actually concrete. In order to model and analyze slab in SAP2000, the following methodology will be followed. Okay, the methodology is mainly divided into three phases. In phase 1 is related to pre-processing, where different model properties are defined, like new model, define or edit grid lines, define materials, define area section, define load pattern, load combination, load cases, and draw area section, meshing of area section, then assign joint and loads. Okay, in second phase, it is related to the analysis, where the analysis is performed and where different load cases are set to run, right? In third phase, it is called post-processing phase, where the different results are displayed, like shear force, bending moment, deformation, and different kind of stresses in area element. Now I will discuss every step in the upcoming slides. Okay, now phase 1. In phase 1, first step is to create a new model, and second step is to define or edit grid lines. Okay, for the given example, we require two grid line in x direction and two grid line in the y direction. Okay, and the spacing along x direction is 20 feet and the spacing along y direction is 10 feet, right? Okay, step 3 is to define materials. Okay, for materials, kindly refer to lecture number 3. Okay, step 4 is to define area section, right? In order to define an area section, go to define menu, then section property, then select area section, and then choose shell. And when you choose shell, then go to add new area section. Okay, when you click on the add new area section, so shell section data will open. Okay, in this form, first of all, you will enter the section name. You will define the section name. Then the second option in this data form is the type of section. Okay, so for the type of section, kindly refer to lecture number 2. I have discussed all different type of section, the area section, in lecture number 2. Okay, then the materials, the material name is actually import or add the material type. Okay, that is defined in the step number 3. And then material angle. Okay, what is material angle? It is actually specify an angle to modify the local axis of the area object to which this area section definition is assigned. Okay, next input parameter is the thickness of the slab or shell element, and you will specify the thickness in membrane and bending. Okay, membrane will give you in plane behavior and bending will give you out of plane behavior, right? Okay, when you will keep bending 0, so it means that the slab will not bend and the beam will carry a larger load. Okay, next parameter in shell section data is modify and show shell design parameter. So I will discuss this parameter in the next slide. Okay, when you click on the modify and show shell design parameter, so this window will open. Okay, this window is actually related to the rebar layout option. Okay, there is 3 rebar layout option. One is default, 1 layer and 2 layer. Okay, what do you mean by default? When you click on the default or you check the default option, so it means that 2 layers of reinforcement will be provided and the cover is actually 0.1 times the thickness. Okay, when 1 layer layout option is selected, it means that 1 layer of rebar in direction 1 and direction 2 is provided, and the location distance will be specified from the top of the section to the centroid of the steel or rebar. Okay, and the distance will be entered in the cover to centroid of the steel, top bar direction 1 and top bar direction 2. Okay, if 2 layer rebar layout option is selected, it means that 2 layer of rebar will be provided at top and bottom of the cross section along 1 and 2 direction, right? Okay, the location of these 2 layer will be measured from the top and bottom of the cross section, right? And it will be entered in cover to the centroid of steel, top bar direction 1, top bar direction 2, then bottom bar direction 1 and bottom bar direction 2. And the direction 1 and 2 are the local axis direction of the area object. Okay, now let's see how to define a shell layered cross section. Okay, area layered section contains interconnected layers of same or different materials casted in the form of distinct layers. right? In the figure, the reinforced concrete sandwich panel is shown, and it is one of the example of area layered section, right? While excluding the polyester, the reinforced concrete sandwich panel is composed of 5 layers. Okay, the first layer is the concrete, this pink layer, and for example its thickness is 1.5 inches. Now the second layer is of rebar, right? And the third layer is the expanded polystyrene foam, and the thickness of this layer is 4 inches. Then again the layer of concrete on the other side, and then the layer of the rebar. Okay, the total layers in this reinforced concrete sandwiches are 5, and the total overall thickness of reinforced concrete sandwich panel is 7 inches. Okay, now let's see how to define reinforced concrete sandwich panel in SAP 2000. So go to define, then section property, then area section, select shell, then new type to add, then click on the shell layered or non-linear, right? Okay, this window will appear when you click on the shell layer. Okay, first of all it will give you the layer name, then distance, thickness, type, number of internal points, then materials, material angle, and there is some material component behavior. Okay, now let's see how to specify different layers and its location. Okay, first of all you will specify a reference line. Let's suppose this portion is the reference line, or it is the top of the concrete layer, and I consider this is a reference line. Okay, all other distances will be measured from a reference line to the centroid of that particular layer. Okay, the first layer is of concrete, and this is a layer number 1. Okay, the distance of this concrete is from reference line to the centroid is actually total is 1.5, so the half will become 0.75, and the thickness of this layer is 1.5. Similarly, the second layer is expanded polystyrene foam, EPS, and the distance from radius RL, that is the reference line, to the centroid of this section is total is 3.5. okay, because this is the centroid of overall section, and the thickness of this particular layer is 4 inches. And third layer is again the concrete on the other side, and the distance from the reference line to the centroid of this layer 3 is 6.25, and the thickness of this layer is again 1.5. Now layer 4 is of rebar at this location. Okay, this type of rebar. Okay, the distance of this rebar from reference line is again 0.75, and the thickness or the diameter of this rebar is 0.125, right? And the fifth and the last layer is here again the rebar at the other location, and the distance from reference line to this rebar is actually 6.25, and the diameter of or the thickness of this rebar is 0.125. Okay, this is the way to define a layer section in SAP 2000. Okay, for step 5, 6 and 7 kindly refer to lecture number 3. Okay, step 8 is to draw area section. In SAP 2000 there is 3 options are available to draw any area section. First one is to draw poly area. Okay, by this way you can draw any irregular area. In the second option you can draw a rectangular area. Okay, this is for the simple area. And the third option is to draw a quick draw area, where you can draw a single click any kind of area at particular grid lines. Okay, in the example I will draw area section by using the rectangular area option. Okay, so just click on the draw, then go to a draw rectangular area, right? So this window will appear. From here you will select the section of area section that you want to draw. Okay, so the rectangular area is drawn by usually by diagonally, and just click on the one diagonal point and then on the other, right? So the area will be drawn. Okay, step 9 is to mesh area, and it is also called discretization. In this step the area will be divided into different objects. Okay, actually a mesh is a network of line elements and interconnected nodes used to model and structure system and numerically solve for its simulated behavior under applied loads. SAP 2000 allow area object to be divided into smaller object in the object based model. Okay, Okay, meshing of area is required to obtain more refined result. Once you divide your area into different boxes, so it will be appeared in this format in SAP2000. Okay, how you will mesh your area? First of all, select your area, then go to edit, then click on the edit area, then click on the divide area. When you click on the divide area, so this different option will appear. So by using different option as per your requirement, you can divide your area into different nodes and interconnected elements, right? Okay, when you choose the first option, so in this option it will divide area into number of object along x, it is shown by 0.1 to 0.2, and along y along 0.2 to 0.3. In the second option, in this option you will specify the maximum size of mesh along x direction and maximum size of mesh along y direction. This third option, you can divide your area along point on area edges, right? So either this point on the area edges, either in the form of intersection of grid lines, or in the form of intersection of line object, or in the form of other points that is selected along area edges. Okay, in third option you can divide area along selected point or line object, and the point or line does not need to be lie on the edges of the selected area object. Okay, in this fourth step you can also divide area along selected point or line object that is actually lie on some other local axis. So for that you will specify the rotation angle for that particular local axis. In fifth step you can divide area into selected point and lines, but in this option you will specify the maximum size of divided object only. Next step is a local axis for the edit points, and use this checkbox to specify that the local axis definition for new points on the edges or face of the area object, right? Okay, if you define any local axis previously, then use this option, otherwise keep both option unchecked. Okay, the last option is related to the restraint and constraint for edit points, right? So the first option is add on edges when restraint and constraint exist at adjacent corner, right? And the second option is selected when add on face when restraint and constraint exist at all corner points. In this option you will add restraint and constraint for edit points. Okay, this will provide a connectivity between different points and its connectivity with other members. Okay, in the example I have divided the area into different points by using the option number 1, and I divide the area into 10 points along x and y direction, right? Okay, now step 9 is to assign loads or joints, if any. Okay, for load assignment, just select your area, then go to assign, then area or point load. Okay, then go to the gravity or UDL, etc. This kind of window will open. Okay, from here you can apply dead load or live load or any other kind of load. So put if the load is uniform, so put the magnitude of this load in here, and then the coordinate system. Okay, if you are working in the global coordinate system, then select global coordinate system, then select the direction of load. Okay, then the distribution of load. If the slab is one way, or if the load is distributed along one way, so choose one way, or if the load is distributed in the both ways, so choose both way option. Okay, once the load is applied, so it will be shown in this form. Okay, this is final model of slab for the given example. Now phase 2 is to run analysis, and phase 3 is to check different results like forces and stresses in shell element. So for result, go to display, then click on the show forces and stresses, then choose shell. When you click on the shell, okay, from this window you can display different kind of results. Okay, component type is actually the resultant forces. In the resultant forces you can display the forces and bending moment and the shear force diagram in different direction, right? Okay, for these different type of components, refer to lecture number. Okay, in shell element, the result will be displayed in the form of contours. So you can set your contour ranges, minimum range and maximum range, and you can also display stress averaging at all joints or over object, and similarly you can also display your deform shape. Similarly, if you want to check the shell stresses values, so you check this component type and it will display different stresses result. Similarly, if you want to see result in the shear layer stresses, so you can also check that values as well. Okay, on left side, the layer stress von Mises diagram is shown, where the different stresses are shown in the diagram, right, in the form of contours. Similarly, at right side, a deformed shape is shown. Okay, this is all about analysis of area element or slab. Okay, now application of group command. Group command is used to add similar type of section into group in case of complex structure analysis. It will make easy for you if you want to reassign section to more than one member, right? Similarly, if you want to assign a same kind of load to more than one member, so for that you will make a group of particular similar type of materials, similar type of section, and you will just go to group and select this particular group. So overall full elements that is included in this particular group will be selected, and you can easily assign or apply load on all these member in one go, and it will save you a lot of time and resources. Okay, in order to create a group, first of all select all members where you want to assign to a group, then go to assign, then assign to group. Okay, when you click on assign to group, so this window will appear, and then you will create a new group, and then add different members to this particular group. Okay, later on if you want to select, then go to select and then click on groups. So here the list of group will be appeared, which actually created by you. Then click on the group that you want to select. Okay, similarly you can also select your different members on the basis of section or material. You select, then property, then frame section. Okay, then the different list of frame section will appear that actually you defined in the frame section step. So you can select from here the specified cross section that you want to select, and similarly you can also clear your selection by just go to select menu and then click on clear selection. Okay, now replicate command. In replicate command, you can copy or replicate your materials along with members at specific location. How? So for that you will just select the element or group of element that you want to replicate at particular location, then go to edit, then replicate, then click on the replicate, or just click on Ctrl+R. It is a shortcut. Okay, so this window will appear. Okay, there is three options in the replicate command: linear, radial and mirror. So I will just discuss linear. In the linear replication there is three options. One is the increments along x direction, y and z direction, and then increment data. Okay, how many times you want to replicate or copy your data at a specific location, right? And you can also delete your original object if you want. For example, how I can replicate the bottom portion of this structure to the other location. So for that, first of all draw this portion and then select all the member including in this story elements or the member are selected, then go to replicate, right? Okay, now how many times you want to replicate elements? 2 times, so enter 2 in the numbers. Okay, now what is the increment? Okay, what is the distance between this object, original object, and the object where you want to replicate it? So the distance is, let's suppose is 10 feet, so you will enter 10 feet distance. In which direction? It is along y direction. You will enter 10 feet along in dy option, and then enter 2 in the increment data. Okay, when you click on this, so this portion will be replicated in two levels. Okay, now insertion point command. Actually, when you draw your section, so all the section are actually connected at center. Actually, it is connected at center like this, but really the element are connected at tops. So how you will change this connectivity? So for that, select frame section, right, beam or column, then go to assign, then frame, then click on the insertion point. When you click on the insertion point, so for this particular case you will select top center. So when you click on the top center, so the connectivity will be changed accordingly. Okay, now analysis of multi-story building. In the previous lecture, I have discussed different separate component of structure analysis and modeling in SAP 2000. Today class, I will discuss how to analyze and model full-fledged multi-story building consists of different components including beam, columns and slab. Okay, and these components will be subjected to different kind of loading, and I will consider that loading as well. Okay, in figure, 5-story building is shown having multiple bays in each direction. Okay, plan view at roof level shows the configuration and arrangement of beam and column, right? And mainly there is one type of beam in all stories denoted by B1. The dimension of this beam is 12 by 24 inches, right? And it is a rectangular beam. Similarly, column is also same in all stories, and it is represented by C1, and the cross section of this column is circular, and diameter of this cross section is 20 inches. And all beams are subjected to 5 kip per foot load, and that is dead load. And the slab thickness in all level of this building is 6 inches. Okay, the elevation of building is different in both direction along 1, 2, 3 and 4 grid lines, and along A, B and C grid line, right? And both elevation are shown in figure. And there is 3 bays along grid line 2, 3, 4, A, B and C, and there is 2 bays along grid line 1 and D. Now let's see how to solve this multi-story building in SAP 2000. Okay, the following procedure will be adopted, and the procedure contains 3 phases. In phase 1, the different properties will be defined, and phase 2 is related to the analysis, and phase 3 is related to the display of result. Okay, first of all, create a new model and define grid system. Okay, grid system can be defined in different methods, okay, in order to save time. In method 1, separate grid line will be created, will be defined along each column, beam and slab line. Okay, along x direction, 4 column line are required, 1, 2, 3 and 4, and the spacing between these grid line are 20. Now similarly along y direction, again there is 4 column line and 4 grid line required in y direction, and the spacing is again 20 feet. Similarly along z direction, actually the building is 5-story building, so the total grid line required including the base, so 6 grid line required in the z direction, and the spacing between these grid line will be 12 feet, right? Okay, in method 2, only define grid system for first story, and we can easily replicate rest of story along z direction, right? Okay, for first story, 4 grid line required in x direction and 4 grid line required in y direction, and only 2 grid line required in z direction. Okay, in method 1 grid system, you have to draw each and every member separately, or you can also replicate these member into the upper story, but it is a little bit complicated and it will consume time. And method 2 is relatively simple, and it will take not that much time, and you can just draw your first story and then replicate the rest of story by replicate command. Okay, the complete model of multi-story building is shown in this slide, and it is completed in all respect. Okay, once the model is completed, now it is ready to run analysis, and next step is to analyze your model. Okay, just press F5 for analysis. Okay, once the analysis is completed, now you can display different results in the figure. The deformed shape is shown, right? Similarly, you can also display the resultant forces diagram, and also you can display the moment 3-3 diagram. And this is the shear force 2-2 diagram, and this is the joint reaction. Okay, it will give you the joint reaction at support. Okay, similarly you can display other kind of result like F11, F22 and M11 and M maximum value, and similarly M minimum value and shear force maximum value. Now I will solve this example in SAP2000, and let's see how we can model a multi-story building in SAP2000, and I will I will apply method number 2. Okay, first of all create a new model, then go to file, new model, and then set your unit in kip feet, then click on the grid only. So 4 grid line required in x direction in method 2, and 4 grid line required in the y direction, and only 2 grid line required in the z direction, and the spacing between the grid line in the x direction is 20 feet, and along y is also 20 feet, and along z is 12 feet. Okay, then click on OK. Okay, once the model is created, next step is to define the material property, and now I'm going to skip this step, and I keep the material property as by default. And now I'm directly going to define the cross-sectional property. So for that, first of all, I will change the unit into kip inches, then go to define section property and frame section. First of all, I will define a concrete beam. So it is rectangular, the beam is rectangular, and I will change the beam name as a beam, and the depth of beam is, the example is it is 24 inches deep and 12 inches wide, and I am going to change the concrete reinforcement from column to beam. Okay, and then I will define the column cross section, and the column cross section again a concrete, and the section is circular, right? And I'm going to change the name of this section to the column, and the diameter is given by 20 inches. Now click on OK, then OK. Now I will define the area section. So for that, go to define, then section property, then area section, right? And add new section, and I will change the name of this section to slab, and the thickness in membrane and bending is 6 inches. Click on OK. Okay, also I am going to skip the other step in the definition section, including the load pattern, load casing and load combination, and I will keep these property as by default. And now I am directly going to draw the relevant member. Okay, first of all I will draw a beam at first story level at relevant position. Right, and then I will draw a column. So for that I will change the view, right, and then select column from cross section, and then I will draw column at relevant position. Right, and then I will move one step further and again draw column at this location, and again I will draw column along grid line 3. Right, okay, once the beam column is drawn, then I will draw a area section, a slab at first story level, then change the view to XY and click on area, draw option, and then draw area at specific location. Now next I will mesh the area. First of all I will select all the areas, then go to edit area, and then I will divide the area section into 10 points. Right, okay, now next step is to assign joints. So first of all I will move to the bottom, and then I will select all the joints where I want to assign restraint. Then go to assign joints restraint, and let's suppose all the joints are fixed, right? Now next I will assign 5 kip per feet load on each beam. For that I will select, first of all I will select all beams. So for that go to select, then go to properties, then frame section, right? So I want to select beams, all beams, so select beam and OK. So all beams visible in XZ plane, right? So the load 5 kip load is applied on each beam. Now first story is completed in all respect. Now we are in position to replicate the first story to the upper story. For that go to select all the members including beam, columns and slab, and then replicate this first story to the upper story up to 6th story, right? Select all the members. So for that go to select, then go to properties, and then frame section, select beam and column, all beam and column, then again select slabs. So for that go to properties and area section and select slab. Okay, once all the members are selected, now we can replicate it. So for replication go to edit, then replicate command. So we want to replicate the first story along Z direction, and the spacing is actually 12 feet. Okay, I want to replicate upper story, and the spacing between two stories are 12 feet, right? Okay, how many stories are there above first story? So total are 6 stories, so we required 5 story above first story, so enter 5, right? Then click on OK. Okay, in 3D view you can see the first story is replicated up to 6 story, and now your model is ready to run for analysis. For that go to analyze, and then start run analysis and click on run now. Okay, analysis is completed. Now we can display different result. So for that go to display and show forces and stresses. If you want to check the stresses and forces and frame elements, so for that go to select the frame, right? You can check the bending moment diagram for frame element are displayed, right? Similarly we can display other results, like if we want to check the result in shell element, let's suppose shell stresses and S maximum values. So S maximum value will be displayed on shell elements, right? So the stresses value in the shell element is displayed, that is maximum values, right? Similarly you can also display joint reactions. Okay, you can check the joint or support reactions. Similarly we can also display the deform shape. Okay, this is a deform shape, right? So this is all about the example of multi-story building in SAP2000. And now this is a task for the practice. Kindly do this task number 1 and let me know if you have any problem, right? Now thank you so much. This is all about lecture number 7.